Hello, today I'm going over diffusion and osmosis calculations. So there's a little description here about diffusion and osmosis. We have covered diffusion and osmosis already, so this is taking it a little bit further and just doing a little bit of math to show how the rate of diffusion changes with different conditions. When we look down here, I have a bold around this formula that we're going to use, rate, and this little symbol here is proportional. So rate is proportional to concentration divided by distance. That's what we're going to use to answer these questions. So this first one, it lays out a scenario, membrane thickness change. So when we're talking about osmosis, we're often talking about cells and substances moving through cells. So a substance diffuses across a membrane that is 1 millimeter thick. So I have a distance here because it's going to diffuse across that membrane. The concentration difference is 8 moles per liter. So I have a concentration difference. If the membrane thickness increases to 4 millimeters, how does the rate of diffusion change? Well, let's set up our first scenario before we change the thickness. Concentration difference, so that is 8. And I'm going to leave out the units for now, the moles per liter. So we've got 8 over our distance, which in the first case was 1 millimeter. So 8 divided by 1, we get this number 8. Would be moles per liter per millimeter. So this is a rate. Now, in the second scenario, if the membrane thickness increased to 4, that's a new distance. Okay, so this 4 is a new distance. How does the rate of diffusion change? Well, I haven't changed the concentration difference. So that's still 8. But my distance has changed to 4 millimeters here. 8 divided by 4 is 2. That is also my rate. So, has the rate of diffusion sped up, or has it slowed down? Well, the number is lower, so the rate slowed down. Now you could say something, so it says, how does the rate of diffusion change? Well, it's now 4 times slower. And you can also just say, 4 times slower rate. We'll do that. Okay. If this number ended up bigger than 8, then it would have been faster. The diffusion speed would have, or rate would have increased. It's going to be similar on number 2. So I'm going to do another example over here on page 4, comparing 2 situations. So we had 2 situations in the first, but they had it set up differently. This one has situation A and situation B. Remember, we need the concentration difference, and we're going to divide that by the distance, which is given in thickness for membranes again. So between A and B, which situation has the faster diffusion rate? Well, here's my A. I take the concentration difference of 12, divide that by the distance it travels, which is 3. That gives me a rate of 4. Again, I'm leaving out the units for now. And when I do B, B has a concentration difference of 6. And a membrane thickness of 1. So that is 6. So which situation has the faster diffusion rate? That would be 6. So B has faster diffusion rate. All right. Now each one of these is similar scenarios to the first one and then the second example I did. You just have to figure out what it is they're asking for and how you're going to set it up for a simple calculation. If you have more questions, please let me know. Thanks.